All right, guys, so we are going to start into our last section last week here of online learning. So we are going to talk about identities. Now, the first part of your assignment is just a little bit of algebra review, and I tried to make like a couple notes throughout of what the goal is to work through in terms of like your algebra, practicing factoring or multiplying things out. So for example, in this one, FOIL it out and then combine like terms if you can. These two create a common denominator. So there isn't, I don't want to say there isn't like this end goal, perhaps, but you're not like solving for an x value or y value. You're just working on some simplifying. And the directions kind of say that at the top. So here we're going to bring in some trig, and tomorrow this will all kind of tie together. So a trig identity, and you're going to see at the end of this packet a chart that we're going to work through, is a trig equation that is true for all values of the variables for which the expressions in the equations are defined. There are a couple key identities that are going to be helpful when you do eventually get into calculus. So let's try and figure out what some of those are. So using x, y, and r, like we're used to seeing, we're going to write out a couple things here. So it says, set the product of each pair of reciprocals equal to 1 and replace the ratios with known trig functions. So for example, we know that sine, okay, is y over r. Its reciprocal, okay, the other trig function that goes with it, is cosecant. So I'm going to kind of do two parallel things here. Okay, cosecant, oops, not cosine, excuse me. Cosecant of theta is r over y. It's reciprocal. Well, if you multiply those together, it comes out to 1. Same thing. If you multiply sine and cosecant together, they come out to 1. They are reciprocals. Right? Sorry, the screen's moving here. Okay, that is important. Oh, God. Okay, so let's talk about cosine. Okay, if we take its reciprocal, so cosine is x over r, its reciprocal is secant. Well, secant is r over x. If you multiply these together, those cancel, you get 1. Same thing here. Cosecant and secant, its reciprocal. When you multiply them together, they turn into 1. Let's do the same thing with tan. So tan is y over x. Its reciprocal is cotan, which is x over y. That comes out to 1. So when you multiply these together, those come out to 1. So I'm going to fill them in to our chart here at the very, very end. So those are our reciprocal identities. So if I take sine theta times, why do I keep doing that? Cosecant theta, it equals 1. If I take cosine theta times secant theta, they equal 1. And if I take tan theta times cotan theta, they equal 1. All right, let's go back and find some others. So the ratio identity. So it says using the ratio sine theta divided by cosine theta, okay, as a starting point, we're going to define the ratio in terms of x, y, and r, and then simplify to determine another equivalent trig function, or trig identity, excuse me. So we have sine theta divided by cosine theta. Well, we know that sine is y over r, and cosine is x over r. So in terms of algebra, we know that when we divide by fractions, instead, we can multiply by the reciprocal. Well, notice those r's cancel, and we're left with y over x. Well, at the end of the day, we know that y over x is tan theta. So sine theta divided by cosine theta is equal to tan theta. Okay? Now let's repeat that process, but notice we have the flip of it, cosine divided by sine. So if I have cosine theta divided by sine theta, well, we know cosine is x over r and sine is y over r. So let's multiply by the reciprocal of our denominator. So that would be r over y. Those r's cancel, and we get x over y, which we know is cotan theta. All right, so those are going to come down here in our chart, and we're going to fill in. Those are our ratio identities. So sine theta divided by cosine theta is equal to tan, and cosine theta divided by sine theta is equal to cotan theta. All right, let's go back up. Okay, now the Pythagorean identities. So you're used to saying, okay, Pythagorean theorem is a squared plus b squared equals c squared. Well, in terms of x, y, and r, it's x squared plus y squared equals r squared if we use x, y, and r instead of a, b, and c. Okay, so what we're going to do here, we're going to take x squared plus y squared equals r squared. It says divide each side of the equation by r squared. So if I divide everything by r squared, Well, x over r, I'm going to rewrite it. They're both squared, so I'm going to rewrite it like so. Same thing here. On r squared over r squared is just 1. Well, x over r, that's cosine. So the first piece is the same as cosine squared. Y over r, that's sine, so that's the same as sine squared theta equals 1. This is important. Okay, this is the biggest Pythagorean identity of them all. Cosine squared plus sine squared equals 1, or you could say sine squared plus cosine squared equals 1. It doesn't matter. I'm going to fill that guy actually in right now. That is like probably the most important Pythagorean identity. And I'm going to go through how basically from that one, we can prove all the others in this box. Okay? Now, if I do that same idea, they do it with the x, y's, and r's. I'm going to come over to the side here and do it a little bit differently. So if I take this equation that we just saw, okay, I claim from this one equation, I can get every single variation, and there's 9 different variations. So let's divide everything by sine squared. There's Pythagorean identities with sine and cosine. There's also Pythagorean identities with tan and secant, and there's some with cosecant and cotan. Okay, so say I want the one that has, I don't know, let's say cosecant in it. I would divide everything by sine squared because we know 1 over sine is the same as cosecant. Okay? Maybe you didn't see that yet. Hold on. Let's back that up. Let's fill in the rest of this section of this chart. My bad. Okay? So if I take this, we'll push pause on what I was just doing. We'll go back to that in a second. If I take this right here, I can do different variations of it. So I could divide each side by sine. If I divide sine over, I can see that cosecant theta is the same as 1 over sine theta. In the same token, I could also divide cosecant over, and I can see that sine theta is equal to 1 over cosecant theta. So that's what they mean by variations here. You can just move stuff and manipulate it algebraically. Same thing here. I could divide cosine over, and I would get that secant theta is equal to 1 over cosine. I could also divide the secant over, and I can see that cosine theta is equal to 1 over secant theta. Same thing here. I could get cotan is equal to 1 over tan, and tan is equal to 1 over cotan. Okay, so there's a bunch of variations. So let's go back up here to what I was saying. So if I wanted to get another Pythagorean identity that had cosecant in it, 1 over sine is the same as cosecant. Now it would be cosecant squared because the sine is squared. So sine squared over sine squared is just 1. Now, we just saw before that cosine over sine was the same as cotan. Since they're both squared, that would be cotan squared theta, and this would be cosecant squared theta. Okay, so let's bring that guy down to our chart. So 1 plus cotan squared equals cosecant squared. Okay, and I'll do the variations of all these in a minute. Now, let's say I wanted to do this, and instead of dividing everything by, I'm going to start over with the sine squared plus cosine squared equals theta, or sine squared plus cosine squared equals 1. Instead of dividing everything through by sine squared, now let's this time do everything by cosine squared. Well, we just saw that sine over cosine is the same as tangent. Now they're both squared, so it would be tangent squared theta. Cosine squared over cosine squared is just 1. And then 1 over cosine, we just saw below, is the same as secant, but since it's squared, it would be secant squared. So let's bring that one down. Tan squared plus 1 equals secant squared. Now, let me be very clear. Sometimes kids think, oh, well, if I have sine plus cosine, that equals 1 too. No, that does not. They have to be squared. Same thing for these guys. Okay? So I claim that if you know this top one, sine squared plus cosine squared equals 1, say you can't remember these, all you have to do to get them is divide the whole equation by sine squared for one of them, divide the whole equation by cosine squared to get the other one. And then the variations will fall out from there. So the variations are basically just solve for different pieces. So let's subtract cosine squared over. So sine squared theta equals 1 minus cosine squared. For the other variation, always go back to the original. let's subtract sine squared. So cosine squared theta equals 1 minus sine squared theta. Basically, the variations are solve for each of the different pieces. So each piece is isolated once. So here 1's isolated, here sine squared is isolated, here cosine squared is isolated. Here 1's isolated, cosecant's isolated, sine's isolated. Same thing for the others. So now for this one, and it doesn't matter which one goes in which box, as long as you have each variation once. So for this one, let's subtract cotan, excuse me. So 1 equals cosecant squared minus cotan squared theta. And then which one didn't we isolate yet? Cotan. So let's do cosecant squared theta minus 1. So for this one, let's subtract 1. So tan is isolated. And then let's subtract tan. So the 1 is isolated. Okay. This right here is super, super important. And like I said, I claim if you can get these, you can do all the variations from there. It's just a matter of algebra from there. Okay. So these, like I said, I did these two differently over here. These are just basically manipulations to get the variation. So like here, solve for sine squared. So subtract the cosine over. Solve for cosine squared. So subtract the sine over. So we did all that already. This chart is super important for where we're going to go with some of these in the coming days. Okay? So, please, your goals today are to finish the quiz, complete this algebra review packet. Right? It's just a lot of manipulation, factoring, common denominator, multiplying, etc. And then watch this video. I will push out a blank page of this in the coming days and go through some examples of where we're going to go from here. I hope you guys are doing well.